Okay, so I welcome you all again to this Math 106 Applied Calculus. So can you see the OneNote thing?
Yes.
Yes,
Oh,
yes, sir, it's clear.
okay. So the objective of today's class is to study a new chapter, which is 11 point or chapter number 11, and the section is 11.1, the derivative. So this topic is actually the continuation of limit, continuity, and then the derivative. So all these three things are the fundamental concept of calculus. And after this derivative, you will see that we will have one more important thing, that is called the integration or integral of some function. So these are the, you can say, four fundamental concepts of calculus in any engineering or any economics or any mathematical problems. So let us start. If you have any other question regarding the previous lecture.
Doctor,
Yes.
please zoom in.
Okay, little bit more. Okay, better now.
Thank you.
Okay, so here the first, before we start the concept of derivative, we need the notion or the topic of the slope of a curve. So in the last lecture, we have seen that if we have a straight line, so then we can, so if we have a straight line there somewhere, for example here, and if there is any 2 points, x1, y1, and then x2 and y2, then we can find the slope formula y2 minus y1 over x2 minus x1. So this was the slope of the line. But here we are talking about, for example, if we have this blue curve, now there is a curve. Now the question is this: what will be the derivative or the slope of this curve? So we know that what is the slope of the line, but we don't know what is the slope of this curve. Okay, so we will seek or we will learn this today. The slope of the curve at some point P. So for example, this is the point P, is the slope, if it exists, of the tangent line at that point. So it means that if there is a curve in the blue one, so first of all, we need a tangent at that one. And I think everyone knows that what is the tangent at this P if we draw the just a straight line. Okay. But the point is this, how to get this tangent. Okay, so let us start the story. So for example, this is the point P and there is another point Q here. And the or the point coordinates are A and F of A and F of A, and another one has like Z and F of Z. Okay, so this is the point A and this is the point Z. So F of Z will be this vertical length and this F of A will be this vertical length, and A is this horizontal length and Z is this horizontal length. So these are the coordinates of the point P and Q. Now if we join these two lines, we will get a secant. So secant is a line which passes through the 2 points of the curve, and we know the definition of the secant. Okay, so now this is PQ is a straight line. So what will be the slope of this secant? This is the slope of the secant. You remember, y2 minus y1 over x2 minus x1. You all agree with this?
Yes.
Okay.
Yes.
So, okay, now what we do? So now we have to be very careful. Now, for example, from this point, we draw Oops. So we draw another line like this. Okay, and now you see we are here. Okay, now we draw another line from here. Now we are here. Okay, now finally for example I draw another line. Oops, this is not working, just a moment. Okay, so what I mean is this line now. So this line is the tangent. Agree? So now what we are doing here, so we are coming from this Q point. So from this Q point, we are coming towards the point P. And if an M, and it means that from the point Z, we are coming towards the point A. Agree?
Yes.
So what is happening here? So if we call this distance as h, it means that this distance is going towards 0. So the whole idea is now, I am summing up that if we have a PQ secant line, and if the distance between the two arguments in the x-axis is becoming very, very small, this secant line will become tangent line. And we know that this tangent is of course a straight line, and the slope of the tangent is again using this formula. So what we conclude? We conclude that the slope of this curve, the slope of this curve in blue now has become the slope of this tangent, and this is what we want. You see, we say that the slope of the curve at the point P, if it exists, is the slope of the tangent at the P, and we have achieved it. So what is the formula? So it means that, so you see, the slope of this PQ line is f of z, means y2 minus y1 over x2 minus x1. Now we say that, so this is, you can say f of z is what? This is an increment in a plus some h. So we can just replace f of z with f of a plus h, and this z was what? This z was a plus h. So when we plug a here, this a will be cancelled out by this, and we will left only h here. So therefore, what we conclude is this: the formula for the slope of the curve at that point will be this one. Is there any question? Is this clear?
So, Doctor, Z approaching A is the same as H approaching 0.
Exactly.
Okay.
So this is just a notation, because z was, we say we add a plus some h. So what will be z minus a? Since z was a plus h, we minus a, we left only with h. So that is, you see, z minus a is h here. Okay, so don't worry, because this is the new concept. So that is why it made some time to understand. But the idea is very simple and also very interesting. You see, first of all, you know what is the slope of the secant which is on the curve, and then you move this Q point towards P, and then the slope at that point on the curve is actually the slope of the tangent at this, and tangent is a straight line, and we know that the slope of the straight line is y2 minus y1 over x2 minus x1. This is the idea. Okay, so let us do one example so that we know how to do the questions. So for example, he says find the slope of the tangent line. Okay, now we have to find the slope of the tangent line to the curve at the point 1 1. So now the question is not like this, that find the slope of the line. Now the question is this, find the slope of the tangent line to this curve. So just to make you more clear, so for example, if there is a curve like this and there is a tangent here, so this is a tangent and this is a point like 1 and 1. Now you see at that point the curve point and the tangent point meets. So therefore at this point the slope of this curve will be same as the slope of the tangent. So this is the idea. Okay, now we start the solution. Since we know that from here we called it like a star, so we know that, so I will make a solution a little bit here. Also the solution is already there, but I just give you the hint. So what was the solution? Solution was limit h approaches to 0 or z approaches to a, both are equal. Okay, so we will use this part. And what this means? This means that we apply the formula f of x plus a, sorry, a plus h. So what is a here? What is a here?
1.
Okay, because it start from, this is the a point, x-axis, and this was the b point. So we say a plus h minus f of a divided by a plus h minus a, we will get h. And now you see this. Is this clear to you? Because we have f of x is equal to x square. So what will be 1 plus h in this case? 1 plus h square. Agree?
Yes.
And this will be cancelled out. It is just straightforward, and from this you see h is common, and then you apply the limit. You are now expert in limit. This h will be 0 and you will get the answer 2. Any question?
Clear.
So I just write it for you for your understanding. Actually all the solution is in front of you. So you see here the solution starts from here. So this is like a limit h approaches to 0, f of a plus h minus f of a divided by h, and this is equal to this one. And this is, he say, everything he writes. So he say f of x is this, a is 2, so therefore this is actually equal to this one, and f of 1 is this one, and h is h. Okay, any question? Okay, don't worry that I will do the questions again and again. There are many questions coming. Okay, so this is the fundamental concept that we have learned so far. that if we have given a curve like this one, and we are supposed to, or we are asked to find the slope of the tangent line to this curve at some point, then what we will do, we apply the formula of this one, the slope of the tangent, and we called it like m small tan, so it represents that this is the slope of the tangent. Okay, so let's move forward. Now the real target was of this lecture was what is the derivative, you see. So we are interested in finding the derivative, but since in the derivative the notion of the slope isn't you say inbuilt, so that is why we learned first this one. Okay, so now we focus on what is meant by a derivative. So a derivative of a function f is denoted by this f prime. Okay, so it is like f and then just prime, and is defined by, so f prime means the derivative is the same. So it means that actually the derivative is nothing but the slope of the tangent. You agree? In the previous slide, we have learned that what is the slope of the tangent on some curve. And here we interested to know that what is the derivative. Derivative means rate of change. So rate of change in dependent variable with respect to independent variable. So this is the philosophy of this differentiation. So I call this again, just for your interest, a derivative of a function f is denoted by f prime, and this is equal to limit h approaches to 0. H approaches to 0 means again the same thing, that from the point q we are coming towards the point p, as I shown you in the previous thing. So this is the idea. Okay, now the same thing, how to find the derivative. So he says that using the definition, or use the definition to find the derivative. So now we have given this function again, and the question is this: find the derivative. And now what we will do, we apply again the same definition, the same definition. Do you agree with this?
Yes.
And then since we have f of x is equal to x square, so what will be f of x plus h? Just replace x by x plus h, so it will be x plus h square. So f of x plus h is x plus h square, and minus f of x is x square. So you come up here, and then you open the quadratic formula, and then x square will be cancelled out by this, and you can take the h common from here, and this h will be cancelled out by this one. Then you plug the limit this h equal to 0, and you will get the answer 2x. Agree?
Yes.
Doctor,
Yes.
be easier to use the power rule to solve this question instead of using the limit.
Yes, this is the next exercise. So in this exercise, uh, we are using the definition. So in the next exercise, you will see that there are properties of differentiation. So we are learning the concept of derivative or differentiation by definition. So this is the definition. Okay, then we have certain rules and properties that are coming in the next exercises, from which we can see that the derivative of fx, so if we have f of x is equal to x square, then its derivative is f dash x, is simply power rule. So what this means, if you have x to the power n and we want to take its derivative d over dx, we will see that there are different notation. So this is means d over dx of this f of x. So there are many notations, and you also know that this is equal to y, and we can also say that d over dx of this y is equal to what. And we also, there are many notation in the book. So the power rule says if m is positive integer or positive, so what the power rule says, you power and one less power. So this is the rule you are saying, am I right?
Yes.
So for example here, so here you say we are taking the derivative of x to the power 2. So it means that power and one less power. So it will be 2x, straightforward. And this is what we have achieved here, you see. But we have achieved using the definition. And this we'll learn inshallah in the coming lectures. Any question? Okay, so here comes another example, the same idea, and I will try to solve it for you completely now. Okay, don't worry. So everyone has done with the attendance.
Yes.
So I have now stopped the response from the attendance. Okay, now as I told you, there are many notations. We write it as the notation of the derivative of this f is like one notation may be f of f dash x, or you can say d over dx of this f of x, or we write it as d of this f, means d is like d over dx, or you can say we have d over dx of this y, or we write y prime. So these are all the notations of the derivative. So notations of derivative, this one. And if you want to say the derivative at this point, so this is the notation for the derivative at the point a, means you can find the derivative at some point as well. Okay, so now let us focus on this example. So what is this example? It says if we have given this function f of x is equal to x square plus 2x plus 3, find an equation of the tangent line or to the graph of f at the point 1 and 7. So this is the idea. So what we do, what we will do, any guess?
Can we use the power rule here?
No, at the moment we should not use this, okay, because we haven't studied the power rule. The power rule is coming in next lecture, but we have to use what we have learned this today. So you remember the first slide. First we need the slope of the point. So slope of the curve will be the slope of the tangent. So if we know the slope of the tangent, we can find the equation of the tangent, because y minus y1 is equal to slope x minus x1. You agree in the last lecture. So this is already written here. We will first determine the slope of the tangent line by computing the derivative and evaluate it at x is equal to this. And once you find the slope, it means that using this point, so this will be x1 y1, and we know that what is the slope intercept form? Y minus y1 is equal to m x minus x1. Agree? Since tangent line is a straight line, so this will be the equation of the tangent line. And for this tangent line, first of all, we need a slope. And what will be the slope? Slope is the derivative of this function at the point 1 and 7. So what is the idea? Actually, it is written here. I don't need to write it again. So first, determine the slope of the tangent line. By computing the derivative and evaluating at this. So we have given. So I am doing it completely now. A complete question for you, that how you will do it. So therefore, f dash x is equal to what? By definition is equal to what? Limit h approaches to 0 and f of x plus h minus f of x divided by h. So my h is not okay, so I will rewrite it. Okay, better. So now what we will do, we just simplify.
Doctor, why are we computing the derivative?
Yeah, this is because this derivative will be the slope of the tangent. You got my point? And this is what is written here. We will first determine the slope of the tangent line by computing the derivative. So this is actually the slope of the tangent. You got the point?
Yes, I
Oh,
guess.
okay. Yeah, this is the point. So that is why we are focusing on this now. Okay, now limit h approaches to 0. So what will be f of x plus h? Where it is x, we replace it by x plus h. Okay, so 2x plus h square plus 2x plus h plus 3. So this is the first part. This is what f of x plus h. Okay, and then minus, it says f of x. So f of x is f of x plus 2x plus 3, and then divided by h. So far so good. And now the thing is that we need to simplify. Limit h approaches to 0. So for the sake of simplicity, you can write 1 over h like this. Okay, and then you just open the square and multiply by 2. So it will be 2x square plus 4xh plus 2h square, then plus 2x plus 2h plus 3, and then minus 2x square minus 2x minus 3. Agree?
Agree.
And now is equal to limit h approaches to 0, 1 over h, and now you will see this will be cancelled out, this 3 will be cancelled out, this 2x will be cancelled out. So what we have left here is 4xh plus 2h square plus 2h. And now you can think of, you can take the h common, and what will be left here, limit h approaches to 0, it will be 4x plus 2 plus 2h. Agree with this? I just take the h common and just rewrite.
Yes.
2
And
square.
now you plug the h limit. It will be 4x plus 2.
Doctor,
Yes.
is it 2 squared and the or we simplify to take the common factor for x plus 2 and h will remain, or what?
So I don't know what you are asking, but from here I take the h common and this h will is cancelled out by the denominator. This is what I did.
Okay.
Okay, so what we have here? So therefore, therefore the derivative of this function is actually 4x plus 2. Now this derivative is actually the general tangent, but we are interested in finding the tangent at the point. What was the point? 1 and 7. So the point was 1 and 7. So it means that what is x here? 1. So 4 into 1 plus 2 is equal to 6. And what is this? So this means that the slope of the tangent to the curve f of x at the point 1 7 is 6. Agree?
Yes.
So therefore the equation of the tangent line. So what was the question? Find the equation of the tangent line. Okay, now we are doing this. So therefore the equation of the tangent line to this function at 1 7 is, now it will be y minus y1 is equal to slope x minus x1. Agree? Or y is equal to 6x, and the 7 will come on the right hand side. So 7 minus 6 will be 1. And this completes the solution.
Doctor,
Yes.
please can you like repeat the common factors part? Didn't get it.
Okay, I will do it here, no problem. So limit h approaches to 0, you can take h common. So it will be 4x plus 2h plus 2, and this h will be cancelled out.
Okay.
So if you want to write it like
Yeah, I get
2h,
confused by that.
okay, because I write in symmetry. Okay, better now.
Yes, thanks.
Okay. And this is what, this is the uh, point slope form. You agree?
Doctor,
Yes.
if x equal x square is from the question.
So you read the question again. So we have this question.
Okay.
So f of x is this.
Okay.
Doctor,
Yes.
the first equation you showed us, which is the m tangent the a instead of the x.
Which first equation? This one?
No, I think it was in the first page.
First page? This one?
Yes, can you go down just one little bit? Yes, this one. M
Mhm.
tangent. Any I can't get the slope of the tangent from this one as well, right?
No, this is the same idea. You see, slope of the tangent is actually the derivative. And this is what? This was the derivative of the point A. This is the same thing.
Okay, that this is what I got confused with. Okay,
Now
thank you.
it is better.
Yes, thank you.
So first of all, we have found the slope of the tangent to this curve. And this question is the same. This is what I have done is the same. And that is why now if you think about, that is why I did not solve the first question completely, because I want to solve this question completely. This was my intention. You got my point?
Yes, thank you.
Because these are all the same things.
Doctor,
Yes.
I'm sorry, but I'm a little confused about the
Okay,
last
no
thing.
problem. No problem, because this is the first thing, and whenever you have a new concept, you have and you can say the problems, not, but that is why you have the homework. So when you do the homework, inshallah it will be okay. And if again you don't understand, you can ask me tomorrow, no problem.
Uh, but about if x equal x square, you see it?
Say it again.
You
Which
said of the tangent line of fx equal x square.
tangent line? What?
Read the question, Green.
Yes, this is the answer. That equation of the tangent line to this curve at this is this one. So what is the question? Find the equation of the tangent line.
Yes.
And this is what we have found. You mean you don't understand this word?
No, I don't understand. If x equal x square, why you put it?
Oh, sorry.
And from where?
Okay, sorry. This is we have to this f of x. I I just write like this. Okay.
Okay, okay.
Yeah. Thanks for the
Now it's
correction.
clear.
Yeah, because I forget to write the complete one.
Okay.
So this is the equation of the tangent in the point slope form. There are many forms. Okay, let's move forward. I think we have learned very well now. We are expert. And now I ask you, this is the same thing. Example number 4. It says find the slope whenever I touch the screen. Sometimes problems. Oh my God. Okay, so anyhow, so the slope What will be the slope of this curve now? Now you are an expert. We have given y. So y is equal to 2x plus 3. So now before we have f of x. So you know that this is also f of x. The same thing. And the slope before we say f dash x. And now what we will say? D over dx over f. And the formula will be the same. And what is the formula? Limit h approaches to 0, f of x plus h minus f of x divided by h. The formula is the same. Agree?
Yes.
Yes.
Yeah, and it is very clear, I think. You just simplify and you will get the answer too. Agree? So you see, I am practicing you again and again so that you understand the concept in the class very well. Okay, now just to make sure, now this is something little bit different. So now I ask you to solve it now so that you know how to do these tricky questions. What do you mean by tricky? So here, so d over dx of this square root. So what you will do, again the same definition, limit h approaches to 0, f of x plus h minus f of x divided by h. So here what is f of x? Any guess?
Radical
Yeah,
square root
radical
x.
of x. Very good. And this is also known as y. Okay. So now I ask you to solve it in 3 minutes and let me know you are successful or not. So you solve it now. And I will ask everyone that who has done it. Okay. So you all have to do. I will give you 4 minutes. Yes, Mr. Abdulaziz, you are there. Mr. Abdullah, yes, Mr. Abdulaziz, you appear offline.
Yeah,
So can
yeah.
you solve this question?
I tried but got stuck.
Okay. Mr. Abdullah Abdulaziz, Mr. Abdullah Khalid, have you done it?
Yes, doctor. But I have difficulty.
Okay. Okay. Mr. Ahmad Auda, Mr. Ahmad Alanash.
I've tried, Doctor, but I got stuck.
Okay. Mr. Ali Muhammad, Mr. Al Bare, Mr. Faisal Fawazi, and Mr.
Yes, I'm
Faisal
fine
Nawaz.
now.
So, are you getting the solution?
Not yet.
Okay. Mr. Faisal, Mr. Faris. So, anyone has get the solution? Not yet. Okay, I will try to solve it for you because
I
it
solved
is
it.
very good. So, let's see how to do it. So, I will try to solve it here. So, again, this is just one step that is different from the previous one because of this radical or the square root. We apply the same idea. So here we have x plus h radical minus this one. Agree?
Yeah.
Yes.
And now the only thing is that now we have to rationalize, means multiply and divide by the opposite sign that we do in the limit question. You remember when we have this kind of problems, what we do? We multiply and divide by such things. And this was the only point that is different. So this will give us limit h approaches to 0. Here we have a square minus b square now. A plus h minus x, and divided by here it will be x plus h and plus radical of x. And here we have left here and we have left only limit h approaches to 0 1 over. So what will be the answer here? 1 over 2 times square root of x. Agree?
Yes.
Agree.
So you see the derivative. So therefore d over dx of the square root of x is this one, and this completes the solution.
Doctor, I have a question.
Yes.
When you multiplied,
Multiply and divide. Yes.
uh, didn't we use that only on if the root is in the denominator?
So in principle, what you are saying, because here in the numerator we have radicals. If we have denominators, then we see some other things. Yes.
I mean, we multiply if the root is in the denominator.
Yes, but here the problem is that the square root is in the numerator.
Okay. I get it.
So actually I am preparing a note for you, so I am making little bit corrections so that when I upload you have a better understanding. Okay, so the last thing is this. There is another concept. You remember we have studied the continuity thing in the last lecture. So we have only 7 minutes left. So there is a connection between differentiability and continuity. So if a function is differentiable, then it must be continuous. What this means, a differential, you say that the limit exists, and this is what we have and function continuous. What was the function continuous? Three things. Function must be defined at that point, number one, so the limit exists, and the third was that the limit must be equal to that point. So these were the continuity things, 1, 2 and 3. And what is in the differentiability? So this is the same. You see, we have limit differential of something f dash is equal to limit, not only the limit but also divided by h should exist, this f of x plus h minus f of x. So it means that their difference will always exist. So this difference is something you can say represent the continuity, because otherwise we are not possible to do it. So if the function is differentiable, then it must be continuous, but the other way around is not true in general. So this is the idea. So and this is an example you will see now. It says that let f of x is equal to x square, and now we know very well what was its derivative.
2x.
Means f dash x is equal to 2x. Okay, and so f of x is equal to x square must be continuous according to this. Because it is differentiable, it must be continuous. And if you draw the graph, so I think it is very easy. So what is the graph of x square?
Parabola.
Parabola, I think this one, y is equal to x square. Okay. Now he says that now we have a function, another function like f of p. This is not continuous at this because f is not defined at 0. You see, thus the derivative does not exist. So if the function is not continuous, there is no possibility that it will be differentiable. But if the function is differentiable, then it must be continuous. You got the point. So I think when you look this again and again, you will understand what I mean. Okay. This is
Doctor,
yes.
you mean the function is differentiable? That means that we can actually have the derivative for it, or what?
Yes. If a function is differentiable, then it must be continuous. But the other way around is not true in general.
Is there an example of not differentiable function?
Yeah, this is the example number 8 now. So for example, you have a function f of x is equal to x mod. Now you see that uh, this function is continuous at this. Why it is continuous? Can you tell me?
There's no
In the
gaps.
Because
yes,
we have the same answer for
in the last lecture we checked that if a
Three
function
conditions.
is continuous at a, what we do? Number one,
Find the value of f if it is exist.
okay, this is f of 0. What was 2?
The value of the limit exists.
Okay, and what was 3?
The value of the f function and the limit is equal.
Zig.
Yeah, this is, so you can check that all these conditions are satisfied for this function when f of x is equal to x mod. Now this function is continuous at the point 0, but there is no tangent line at 0, because at that point we cannot find a tangent, because this is a corner point. You see what is a tangent? Tangent is like if you have a curve like this. If you have a curve like this, then any point here touches this line. So this is called a tangent. But at this point, corner point, this is not a curve, this is a corner. So in principle, we cannot draw a corner. But you can think that we can draw many lines, but this is not correct. You got my point?
Yes.
Because the curve has to be changed. So because here up and down is changing curve, but here if we go left, right, nothing, because it is a corner. So it means that there are a function which are continuous but not differentiable. And this completes today's lecture. And here are some suggested problems. And from now onwards, I will also show you some of the old exam questions, okay, after the next class, because this 11.1 was just introductory. And you see the question is the same. Find the equation of the tangent line to this curve. This is what we have done today. You remember?
Yes, we multiply.
Yeah, but we will use the direct differentiation that we have learned so far. And then there is another question regarding the continuity. So we have to see that the function is continuous on what? So this is from the final exams. So inshallah we have some MCQ questions from the old exam as well, as to let you know what is happening in the exams. And here I stop and say thank you very much. If you have any question, you can ask, or you can ask me in the office hour as well.